Problem 4 states, square ABCD measures 6 centimeters on each side. If the three interior segments divide the square into two congruent trapezoids in an isosceles triangle, all of equal area, what is the length of segment EF? We're first going to start by labeling the diagram. So we are given the information that this is a square and that each side is 6 centimeters long. We also know that these three sections each have equal area. So first we're going to find the total area of square ABCD, which gives us 36. Because the whole square is 36, and each of these three sections has an equal area, we know that each of these three sections is equal to 36 divided by 3, or 12. So we know that all three sections have an area of 12 centimeters squared. Because the problem is asking us to solve for segment EF, we are going to label this as X. And if this is X, this height right here is going to equal 6 minus X. What we're going to do is solve for the area of this isosceles triangle. The area formula for a triangle is equal to 1/2 base times height. 1/2 base, the base is 6 centimeters, times the height, which is 6 minus X, should equal our area, which is 12. So now we are going to solve for X. Keep in mind, X is EF, and that is what the problem is asking. So it is important to always keep in mind what the problem is asking when you're solving for variables. So first we're going to get rid of this 1/2. We do that by multiplying by 2 on both sides. This gives us 6 times 6 minus X equals 24. Next, we divide 6 on both sides. That gives us 6 minus X equals 4. We're going to add X to both sides, giving us 6 equals 4 plus X. Subtract 4 to both sides, and that gives us X equals 2. What we did right here is basically just algebra. So if you review on your algebra notes, you'll understand how to solve for X. I just did it briefly right here. So we know that X equals 2, and we know that X is actually our segment EF that we want to find, and that equals 2 centimeters.